about zebrafish?
So hello, my name is Jamie Shuda. I am a faculty member at the University of Pennsylvania and a former third grade teacher. And when I was going to graduate school, I teamed up with a scientist to start Project BioEYES, which takes live zebrafish to teach students about science and genetics and developmental biology, and is very fun and engaging for students and teachers.
So the ones with the goldish tint are fertilized embryos with black eyes. So you need to catch one of these guys and one of these guys.
Oh my God, take a video.
Very good. You should write that in your observations. Have you? How about their behavior? What do you think? Do they like each other? He quickly realized that there was a need to really engage the general public in this type of research, but also to show them that science is not so stereotypical and that anyone can do science. He developed a program that worked for a classroom. So it was something that any student could do in their normal classroom environment, and that they could learn some really sophisticated science concepts using an exciting organism like zebrafish.
Let's think scientifically. What about zebrafish would be important for us to know? Or why would a scientist want to study zebrafish?
Raise some zebrafish. And each day, you're going to have a certain assignment, a topic that you're going to have to observe and learn about and report back to me. And you're helping us grow the zebrafish so that many, many more students will be able to experience BioEYES after you. The next stage was to develop a curriculum, something that's doable in a classroom. I knew that it would become pretty popular based on what my colleagues and I had for science resources prior to BioEYES. I knew that teachers would really want this.
We considered the ideas, worked with ARMY and with the Australian Stem Cell Centre, and we developed considering how we could make it fit into our curriculum.
I've been out talking to school kids, and this is really high school kids, about science, and particularly about stem cell science. And depending on how well engaged they were, the talks went really well or they went dreadfully. It was almost as though I needed to give them something to touch and feel and to do, and to get them enthused and interested in the area. I could see that it used zebrafish embryos, and I thought, wow, what a great concept, because you know, to be able to watch something grow in a week, it would be great for kids. It'll get them excited.
We decided we wanted to pick a couple schools in order to pilot the program, and so we thought we wanted one secondary and one primary school. Bentley West was the obvious one for me, just because it's a good school that takes on these programs. And John Monash, being a secondary school dedicated to science, and that it's also the inaugural year of the school, we thought that was a good place to run it as well.
So we actually bring in adult zebrafish, and the students get to raise the offspring. So they mate them in their classroom and raise them for 4 days, and they can see development happen in the zebrafish. And because they're transparent, you can see the heart and the lungs and the eyes and pigment form without having to harm the fish. And during this week, depending on the grade level we're teaching, we hit on basic science concepts that are already embedded in their curriculum.
We put the water in the tank like all the way up and from there. And then we went to catch the fish.
The whitish ones, the knocker, and the stripy ones, the wild type.
Also, zebrafish are vertebrates like us, so they have a similar DNA. Vertebrate means we have backbone. Invertebrate means no backbone.
So what's exciting about zebrafish and this whole BioEYES program is that it levels the playing field. It doesn't matter if, English is your first language, or if you're reading on grade level, or if you are the science genius of the class or not. I mean, no one is a zebrafish expert. So all students really get the chance to come alive and really give their all and really become successful at this.
Why are you liking it?
Fun and we're learning something. Yeah. Which I don't normally say.
I think the biggest winner for why we would use this in a classroom is the fact that they're transparent. So we can see everything developing without having to harm or dissect the fish. And from a developmental standpoint, that's really unique in types of models that we study. But also from a teaching standpoint, it's quite exciting to see the differences every day.
Where do we get our DNA from? Our parents.
So you're going to use your pipette to suck up the eggs that aren't fertilized, so the nice bright white ones.
The unfertilized ones have a white center. The ones that are fertilized, they're just clear. Yeah.
So we developed BioEYES student journals that are per grade level, so depending on which grade level you have, the journals are a bit different. And it takes the students through the scientific process. So in the beginning, they're learning some background information about zebrafish and why we would study them. It gives them a space to write down their scientific question that we give, a space to make a hypothesis. And then over 5 days, there's pages dedicated for them to make observations and collect data. And it's really important, I think, for us to instill the skills of making good observations and collecting good data and then drawing conclusions from that. So this book allows them to keep all of that in one spot. And then we also believe that integrating other subjects is important. So there's math activities and writing activity where they get to write a story, and allows for the teachers to check that the students are understanding the experiment, understanding the scientific vocabulary. But it also creates an opportunity for students to be creative and to tell the experience from the vantage point of a zebrafish, or to be able to describe the use of a microscope and things like that.
What else do we need to be doing the next couple of days?
Observing how they develop.
Yeah, great. So in your student journals, we're on day 3 today, day 3 of our experiment. So you need to draw what you see underneath the microscope, and we're going to label them as a class.
Writing our story from the perspective of our little embryos.
I am in a petri dish right now. I am eating medium. 2 kids are using me and all of my brothers and sisters in an experiment. This means we are going to be looked at through a microscope.
We can see the eyes. Yeah, the head and tail have formed distinctively, and you can kind of see like the blood coursing through. And the embryo sac is getting smaller.
So I think that the students respond to the idea that they are the scientists and that they have ownership for what is happening for each day. I think it's a blast to see students discover things underneath the microscope for the first time. And the fact that you never see the same thing twice is really exciting. So they respond quite energetically to that. I think they respond to the questioning. So the fact that we're posing questions and tasks for them to accomplish, and every day they have short-term things they need to do, but also over the week they have one overarching question that they must answer and collect data for. And I think that they enjoy seeing it again from beginning to end and being able to draw a conclusion by Friday.
You can actually see the tail I've got out of it, and then they don't have the chorion around them.
Here we can see a little tail.
A tail coming out, which we didn't see yesterday.
It's like a once in a lifetime experience basically, because seeing a fish hatch basically from an embryo, it's just amazing. Like seeing how it developed, it's like being a parent basically. It's like wow, because I don't know, we first had the adults and then they made it or whatever, and then we got the eggs and then we just watched them grow, and we observed them and we saw what how they were from day one, and they develop really quickly. The next day you come and they've got eyes and spine.
On Monday, I was really excited, and I'm still really excited.
I just reckon the science program is terrific.
And science is really fun.
And breeding zebrafish is so interesting, and it's amazing.
Zoe hasn't stopped talking about it since she came home on the Monday afternoon. She's been very interested in it, and it's been interesting for our family to hear what she's been learning at school, but it's a fantastic opportunity, and yeah, there's lots has already happened in such a short amount of time.
One of the best parts was when Jamie started, because then it kind of hit home that it was finally happening, and she's a really good educator. But then just to see the kids embracing it, I was maybe slightly concerned that the kids, the students at the secondary school, John Monner Science School, would find it a bit too basic, that it wouldn't be challenging enough for them, because these are very strongly academic science students, but they loved it. I mean, they really embraced it. And seeing the primary school kids, you know, looking down a microscope, watching an embryo develop, they were just blown away. I think that was even better than a video game for them.
The excitement for the kids, just talking to the kids. The way she's delivered the science is completely engaging, makes me want to learn more about zebrafish, let alone the kids. And I think doing the program at both a high school and a primary school level has been very informative as well. You can really see how a similar curriculum can be tailored to both age groups.
Well, if I compare it with how I learned out of a black and white book called Jones' Biology, this is much more exciting. And even when you see the drawings in the book, in their little booklets, and then you see it live, you can understand why they're so excited about it. It's cool, they say. That's a word that comes out most often, and that's pretty high praise from a group of school students. I don't think I could have said anything when I was at school was cool.
I think it's been well received. I think that the students are learning a lot, and they're seeing themselves as scientists, which is a really important thing that we want to get across to them.
I can see that we can roll this program out around the country, particularly into rural areas where they don't have as many resources.
I would like to see this as a national program that is being performed or operated at many different schools around the country. I would like to see enough funding that we had a project manager who was running the program, working with teachers to develop the curriculum, working with the scientists to incorporate new cutting-edge research into the curriculum so that the schools would each year be learning new research in science, and that this person would be able to really go out there and train teachers, train and run the program with them, but get a critical mass of schools and teachers participating in this.
It's clear how engaging it is and the students love it. What I like about it also is the microscope work is there, but it's not particularly difficult. You don't have to have that much equipment for it, and you could do it with just a few microscopes, but I think kids love using microscopes, but what's hard sometimes is really focusing in on those small bits of detail and knowing what they're looking at. With this, it is really blatantly obvious, so I think it would really lend itself to any school, and it's got enough difficulty to be challenging, but I do think it can be modified quite easily to fit with any program. So I think any school that had it, it would certainly enhance their program. So I would like to see it in as many schools as possible.
Being able to see it and record it, it's going to be awesome, make a really big impact on the kids, I think. And having the opportunity at primary school as well, I think, is amazing. It's fun that I'm going to be learning it too. I think it's going to give those kids as well who maybe don't excel at reading and writing and all the more academic things to have an opportunity to explore other avenues of education.
And they're actually teaching the science by themselves, and that really is a true mark of sustainability. So if we can get a model like that happening in Australia, then we can keep expanding BioEYES quite rapidly while having these confident teachers that really can help expand the program and help us train new teachers, and it becomes something that the schools have ownership of, and it's not just an outside program.
Look, it's absolutely vital that Australia continues leading in science. We've batted above our weight in medical science and in science, and we need programs like this to make sure that we make kids enthusiastic about science, so that we actually can keep our head above water and keep doing the sorts of inventions and discoveries that we've had in Australia, which have put us ahead of the world in lots of ways.
Experiencing the live type of experiment is very unique, and I think that every student should get the experience to see science that way.